All right, so today's lesson is about the volume of a sphere. So we know that volume is the amount of cubic units that it takes to fill an object, a shape, a three-dimensional shape. So today we're going to talk about spheres. A sphere is a three-dimensional shape. So the definition, though, is that every point on the surface is equidistant from the center. So if the center is right here, it means that any point on the surface, meaning like the edge, think of it as a basketball, every single point is exactly the same distance from the center. And all of these segments that I drew have the same measurement as the radius. So it doesn't matter where I draw a segment, they are all radii. Okay? So the formula for the volume of a sphere is 4/3 times pi times the radius cubed. And tomorrow I have a really cool video explaining a really cool discovery, I guess, video showing you why that is. So volume of a sphere. And then we have a shape called a hemisphere. Now a hemisphere is just half. Hemi is half. So it's half of a sphere. So just half of a sphere. So half of 4 is 2. So the volume for that is 2/3 times pi times r cubed. Now remember, r stands for radius. So it doesn't matter whether you're trying to find the volume of a sphere or a hemisphere, we still need to have the radius as our given measurement. All right, so let's just jump into some examples. Our first example is number 1 says that an iron ball has a diameter of 6 centimeters. We need to find the exact volume. When you see the word exact, when we're talking about volume, that means leave your answer in terms of pi. Because remember, pi is an irrational number, meaning a decimal that goes on forever. So if you use pi in your calculator, use the pi button, it's going to give you that decimal that goes on forever. And that's not exact. It's an approximation, okay? So we are going to find the exact volume of the iron ball, and we're going to find our answer to the nearest tenth. So we're going to give two answers, an exact answer and a rounded answer. So we're given the diameter, but I remember that the formula for volume of a sphere is 4/3 times pi times the radius cubed. Has nothing to do with d. So if I'm given the diameter, can I find the radius? Yes, I can. Remember that the radius is half of the diameter. So if the diameter is 6, that means the radius is 3. So I'm just going to plug this value in. So I have 4/3 times pi times 3 cubed. All right, so I'm going to go to my calculator, and the first thing that I'm going to do is the 3 to the third power, or 3 cubed. And I see that 3 cubed is 27. And then I'm going to take that and I'm going to multiply it by 4 in a parenthesis, 4 divided by 3. So I'm going to write it out so you can see how I put it in my calculator. I do 3, and then I use the caret function, cubed, and I hit equals, and then I use the multiply button, parenthesis, 4 divided by 3. And I find out that that answer is 36. And I still have to multiply it by pi, so this is 36 pi centimeters cubed. Now I also need to give my answer to the nearest tenth, so I'm going to take 36 and multiply it by pi to get that answer to the nearest tenth. So when I take 36 times pi, I get about 113.0 0.09, which rounded to the nearest tenth is approximately 113.1 centimeters cubed. Okay. Example number 2 says find the volume of the hemisphere. So remember, volume of a hemisphere is half that of a sphere, so 2/3 pi r cubed. I know that the radius is 8. And it says to give my answer to the nearest hundredth. That's 2 decimal places. It's not asking for exact like in the previous example, but it is asking me to give 2 decimal places. So let's just plug in that value and see what we get. So 2/3 times pi times 8 cubed. So I'm going to write over here what numbers I'm pushing on my calculator. 8 caret function 3. That's 8 to the 3rd power times parenthesis 2 divided by 3. So if you do that, you should get, close your parenthesis, you should get about, and then we're going to multiply it by pi, times pi. Forgot about that because we're rounding this. So times pi. So you should get about 1072.3302. So if I'm rounding to the nearest hundredth, my answer is 1072.33, and my units are centimeters cubed. So those are my 2 decimal places. Okay. All right, the next one, the composite shape below. So composite, that is just 2 shapes added together. So the word composite means that it's made up of more than one shape. So it says that this composite shape has a height of 8 inches and a radius of 4. So if this shape has a radius of 4, that means this is also 4. But remember what we just learned about spheres, that means this is also 4, so the cylinder can actually only be 4 units tall. So we have a hemisphere and we have a cylinder. So we're going to have to find the volume of each and add it together. So the volume of a hemisphere, 2/3 times pi times my radius cubed, plus the volume of a cylinder, which is the area of a base. The base is a circle, so pi r squared times the height. So let's substitute in these values. So 2/3, whoops, that's a horrible looking 2. So 2/3, and it says exact, so we're going to leave pi as a variable, times pi times my radius, which is 4 cubed, plus pi times my radius, which is 4 squared, times my height, which is also 4. So 4 to the 3rd power is 64 times 2 divided by 3 equals 42 2/3. So this is 42 2/3 pi plus 4 squared is 16 times 4 is 64 pi. So if I have to give my answer exact, let's see, let's do 42 times 3. Let's turn that into, I'm going to turn that mixed number into an improper fraction. So that becomes 128 over 3. So when I turn this into an improper fraction, I get 128 over 3 pi. If you forgot how to do that, that's this, right, where we multiply and add. So 128 over 3 pi, and then I'm going to take 64 times 3 to turn that into an improper fraction. So 64 over 1, I just want to have a common denominator, plus 192 over 3 pi. So 128 plus 192 equals about 300, or actually not about anything, it's exact. 320 over 3 pi inches cubed. Now, you don't have any composite shapes on your homework today. Actually, your homework is 4 questions in Khan Academy. So you have 4 Khan Academy questions. I'm hoping for 7100s. Okay, good luck.